participates in the pool and what direction the train's pointing for. The straight, you also ideally wouldn't have the details of the identity of the participants, but this might be regulated as some regulations are required to disclose a lot of information from the target. And because of anonymity, we don't see the large transactions actually in the order books, which means that there is no impact on the market from the sheer existence of the large order, right? So you can, as an institution, you can send a transaction that is, send an order that says, I would like to buy this extremely high amount of a particular stock, and nobody will see that order, so the market doesn't move just to the reaction of the existence of the order, which is totally opposite to what we would expect normally in blockchain with the mempool, right? Whenever I send the order to the mempool, if the order is significant, then someone could see it as the market moving order, also obviously front-running or act in general with the MEV extraction in mind. It creates the liquidity environment for large institutions that normally would be afraid to execute on the market, or to execute very inefficiently for splitting the orders between multiple different brokers, multiple different venues. I have to manage manually the execution of the order. And as a result, we also can have better pricing, because within the dark pools you can operate algorithmic execution of orders. So not only you send the order to the dark pool, but you can also define the concepts that in blockchain would call like programmable privacy. So you send something that is private, but you also send some instructions or use some algorithms provided by the dark pool operator saying how that order should be executed. Now, those dark pools will be operated by large financial institutions, right? So they not, the exchanges, like in the sense that exchanges are also operated by some institutions, but you consider that they're not public goods that are available for everyone to join. That's why also we're talking about the large institutions. Usually those participants will be verified, vetted by the operator of the pool, and you have hence like limited access to the dark pools themselves. And also, you don't have what normally we would expect from blockchain. So we don't have the trustlessness. We have to trust those institutions, but they'll maintain all those guarantees of privacy. The privacy is only guaranteed because in your contract that you sign with the institution operating the dark pool, you're being promised that your transaction will not be disclosed, that this transaction will not be disclosed, and the algorithmic execution will happen as it is described in the contract. Inside the dark pool, all the matching mechanisms happen, usually at the midpoint of the prices coming from either inside the dark pool itself or from the venue that is used for pricing by the dark pool operator. And those institutional operators, the participants of the dark pool that we mentioned would be hedge funds, would be brokers, institutional investors, and those are the ones that try to avoid being seen. Now, the regulators started very soon looking at the dark pools very closely, because that privacy guarantees, the promises made by the large institutions could be broken, right, in various different ways. So after a while, we had a series of very visible cases where SEC sued the operators, saying that some of the guarantees from the contracts were not really held in reality. I'll mention a few examples of those from the publications from SEC. So now, the dark pools theoretically guaranteeing all of those good sides, but what would be the problem? So the lack of transparency that's in blockchain, when we say, oh, there is privacy, lack of transparency becomes privacy, but also blockchain usually delivers transparency of the rules. You know that the rules are very clear. You can read how the smart contracts behave. You can read how the cryptography behaves. In this case, well, you have the contract that describes how the system should work, but you cannot really look at the system itself. You cannot verify if everything is executed, And the lack of transparency that is meant to be privacy becomes a problem because actually you cannot verify if everything is right. All the furthest concerns in a sense of, well, the trust for the operators. Do they really execute the algorithms the way they promise? Do they give someone the unfair advantage? Like maybe in a commercial agreements context, you can have some particular operators or maybe even internal players within those banks and institutions acting on the trades with maybe other operators, like paying for access for better execution algorithms or paying for access for being the first to execute. There are concerns with the solutions like the routing to internal matching systems even before sending the orders to the dark pools. And here are a few examples of like the types of data leakage or data sharing practices that we're seeing noticed among the dark pools operated in traditional finance. So the early access to trade data for some of the high-frequency trading firms was actually allowed by some of the operators. The privileged access to some of the data feeds, so sometimes the internal teams, for example, like marketing or sales teams, had access to the information about what type of trades different clients can execute, so they could actually have better access, like better materials, sales materials, to offer other products or to increase the sales through the dark pools. The bingo orders, so the ability for some of the participants or even all of the participants to learn how the dark pool operates with a series of small trades, like testing the water, testing what trades are exactly inside the dark pool. The order routing problem. So as I mentioned, sometimes the actual execution venues that the dark pool would execute on would not be disclosed, and the trades would be sent outside of the institution operating dark pools without information provided to the participants themselves. So the routing would go to the external brokers, or simply for the internal ports, like internalization of trades, the routing would, as I mentioned, go through the internal matching engines in the institution before going to the dark pool. And very often this would be with the worst pricing that it would be if it was executed through the dark pool. And a special algorithms access for some of the operators. And here we have the case from 2016, that was SEC against Barclays and Credit Suisse. And in the end, you see the penalties, the 35 million penalty and 30 million on Credit Suisse, Barclays and Credit Suisse respectively. And the publication is visible at the link. And here you have, at the same link, you have a list of all the different fines that were given to the dark pool operators. So Barclays 35 million. This is 2016 document, and you already have a few others after that that were also significant in the settlement size. So let's read this one. So Barclays misled dark pool customers about the data connection speed and about the surveillance executed on the trades inside the dark pool. So they were promising that the consistently there are algorithms that are verifying if some toxic trades are happening on the dark pool, and actually that those algorithms were not executed. So they were not executed weekly, they were not executed in general. Credit Suisse, this is a bit more complex, so let's read about this one. They operated a secret trading desk that accessed confidential data about the dark pool customers, right? So internal access to the dark pool. Failed to inform all customers about the order type that gave advantage to orders from market makers and high-frequency traders. And even more. So you can allow an affiliate to access and use those customers' confidential trading information. Fail to protect customers by allowing marketing and sales teams to access data. Outside firm to access and use customers' confidential data. And misled the dark pool's customers on the information how the algorithms really work. So all of those fines settles with SSC. And many new projects coming to the crypto space, saying, well, the dark pools can be offered in a better way with the use of cryptography protocols, solutions, and as you see, like they charge protocol fees for all of this, and most of them are under construction. Renegade just announced their project, I think on top of Arbitrum Stylus, and they, so maybe I will mention that as well. And it seems like, I feel that for many, many years, it felt very natural that what we were really building for the success of trading blockchain was dark pools. That maybe you avoided the topic, or not always, like people are mentioning here and there, but the ultimate win of blockchain is that you can deliver a dark pool that guarantees all those rules not to be broken, that will be fast and efficient, will provide the best price execution. Now, that fast and efficient was definitely for a long, long time a problem. And I feel like nowadays we are entering the stage, entering the era of blockchain actually delivering the speed of execution that was needed to have very efficient trading. And I feel like that we have a bit of a delay in reaction to the advancement of the technology in the last few months, with the ability to onboard users, with all the speed coming from the new protocols, from L2 on Ethereum or from Solana, and this will be all very, very promising values. Now, not only does guarantees the privacy, but also give you the permissionlessness, right? So you can have small retail players to access the dark pools and execute there. It also means that you have concerns about all the regulatory aspect of, do you allow the malicious operators to enter the dark pools and execute there? Maybe they, maybe trading the illicitly obtained funds. So the cryptography methods used, either a combination of MPC and ZK, or very often solutions based on TEs, so hardware-based solutions. And well, TEs are becoming a bit more and more of the talk of blockchain. And I think that when I was analyzing different protocols, the ones based on TEs were promising something around 80 milliseconds for the trades to be actually matched and executed, while Renegade, I think, was promising around 200 milliseconds for the trades to be settled. So this might be related to the arbitral timings of the blocks. The automated trustless execution, and well, everything that I mentioned, the access to the retail investors, and actually in the end, when you think about the blockchain, the crypto, all of the ability. So in the sense that, well, it's blockchain, so you can settle any information on chain and give it for to any regulators to review. At the same time, ensuring that there is a privacy on the parts of the trade that shouldn't be disclosed to anyone. So anyone who enters the dark pool knows exactly what information will be released ever, right? Like you know the rules, so you know if those rules allow for your trades to be disclosed post-trade, you know what will never be disclosed. So ZK, MPC, TE, and something I want to mention, I think that's stratification that is slowly happening in different protocols. And what I mean by stratification is that like nowadays the blockchains are a bit like on the left, like so the dark assets, the assets from unknown sources are a bit mixed with the assets that are freshly minted. And somehow we think that the only way might be separating them entirely. That you can either have the chain that exists with the assets that are all clean, KYC, verified and regulated, or you can have a chain that is all dark and only criminal activity. What happens really is that blockchains should be very much neutral in what they allow to be there, but any assets, but any trading value that allows liquidity flow in may allow that liquidity to only limit interactions with the protocols and with the assets that are also fresh and verified. Which means that you, and actually this happens in the dark pools proposal that I mentioned before. So here are a few links. Thank you so much for listening. Over to your remarks.
For our next keynote titled Arbitrum, Onboarding Next Generation of Users onto Web3, We have Ed, the co-founder and chief scientist at Off-Chain Labs. Please welcome him to the stage.
Good morning, everybody. I want to talk about the future of Arbitrum. I want to talk about where Arbitrum is as a typical and I think the most successful layer 2, and more importantly, where we're going. But I want to start with the first rule of Arbitrum, which is your chain, your rules. What that means is that the Arbitrum technology is not a single thing. It's not the goal to impose some kind of top-down uniform governance system across all Arbitrum chains. The idea is that each chain should be able to make their own decisions about what they want to do, how they want to set the parameters, which upgrades, which software versions to do. If you're in the Arbitrum ecosystem, you can have your own chain, and you can set the rules for your own chain. And for the same reason, the flagship Arbitrum 1 chain is controlled completely by the Arbitrum DAO. Okay. Now, I want to put these statistics up because I think people often don't realize to what extent the layer 2 roadmap of Ethereum has succeeded. Today, layer 2 and layer 3 in the Ethereum stack accounts for about 30 times the transactions per second of layer 1, about 80 times the gas usage, about 40 times the call data, spread across more than 50 L2 and L3 chains. So to first approximation, almost none of the activity in the Ethereum stack happens on layer 1. And yet today, many of the conversations about blockchain design in the Ethereum stack are focused on layer 1. In fact, what people find even more surprising is that the majority of activity in the Ethereum stack happens at layer 3. Layer 3 is the most, layer 2 is in second place, and layer 1 is far behind. So we're in a different world. All right, but where do we go from here? We've gotten there through the sort of initial rounds of L2 and L3 design. Moving forward, I want to talk about a bunch of features that are coming to Arbitrum or are on the horizon. Stylus actually launched yesterday, Bold, and I'll talk about a bunch of these. Okay, so first let me talk about Stylus. This just went live on mainnet yesterday, and I think it's it's one of the biggest upgrades that has ever happened in Arbitrum. I think it's one of the most important, perhaps the most important upgrade in the execution model in the Ethereum stack that has happened since the invention of the EVM. It's the next generation programming environment for Arbitrum chains. What it lets you do is it lets you write smart contracts in a broad variety of programming languages, Rust, C, C++. You can compile them to WebAssembly and then deploy them directly to an EVM compatible chain. And that's the key. It's not a separate chain, it's not a separate silo. Smart contracts can be written in any of these languages, and they're fully interoperable and composable with EVM contracts. EVM can call Rust, Rust can call C++, C++ can call EVM. All of this works together seamlessly on the same chain. And not only that, so for example, here's a code example written in Rust. It calls a standard Rust library, which of course you're perfectly able to do. And you just decorate the code with this decorator here telling the compiler toolchain to compile this to run on Arbitrum, and it works. You can deploy that as a contract. The other big unlock here is performance. Because the WebAssembly virtual machine is so much more efficient than EVM, and because the Rust compiler generates more efficient code than the Solidity compiler, you can get up to 70x improvement in computation speed. Thomas mentioned Renegade Finance. They launched their application on Arbitrum yesterday using Stylus. Their implementation uses secure multi-party computation. That is too computationally expensive to do on an EVM chain. It simply can't be done. But on Stylus, they can do it and deploy it. And so they are the first significant application to deploy on Stylus. They literally were waiting for Stylus to go live on mainnet. That's the kind of unlock that you can get. That went live, as I said, yesterday on on the Arbitrum One mainnet. It's available to all other Arbitrum chains. Under the your chain, your rules principle, each chain decides for itself whether to adopt this. The next big upgrade that's coming soon, assuming that two chains that choose to accept it, is Bold, which allows efficient and fully decentralized proving in an optimistic proving framework. It's the first and only fully secure, fully decentralized fraud-proof mechanism that will allow this, I think, incredible guarantee to be provided that any one user, and it could be any of you, is able to enforce the safety and progress of the chain using equipment that you have. That's what Bold unlocks, and Bold is, it's been well through testing, it's been through audit, and we expect it to be before the Arbitrum DAO for a vote before long. Those are the things that are definitely firmly in the pipeline. What else is on the horizon? There's a bunch of areas. Pushing performance, pushing the amount of throughput you can get on one chain is a big part of that. Stylus is an important step because it makes execution, fast execution available if you use Rust or C++ or one of those languages. Working with alternative client integrations. Currently, the stack uses GAP, but integrating with other clients, perhaps Ref, Aragon, Nethermind. We're looking at that to try to understand how much performance you could get and which of these options looks best for the community. There's a lot of interesting work to be done about more efficient pricing and more efficient resource limiting. The gas accounting system and the gas limit and pricing system on Ethereum is essentially a way of regulating how much activity can happen to make sure that nodes are able to keep up. Well, by doing more precise and more clever accounting and limiting and pricing, we think that you can squeeze a significant amount more performance out of the same nodes. Because nodes currently are not running at their capacity. Even the sort of minimal 4-year-old laptop nodes are not running at their full capacity all the time. And the next piece of this is cross-chain interoperability to allow fast and trustless interoperability across chains. That allows you to do horizontal scaling, where you can get more activity on your application by launching a bunch of sharded chains that interact closely together. There's a whole set of sequencer improvements. Let me talk about that a little bit. The Arbitrum sequencer today has a really unique set of advantages. Fast response time for user transactions, a fraction of a second. Very fast arbitrage time, that makes DeFi markets operate very efficiently. It almost never reorgs in the entire history of Arbitrum. There's been one reorg affecting 3 transactions. You protect users from front running and sandwiching by hiding the mempool, and the approach is simple, fair, and easy to understand. But there are 2 more things. That's all true today from the Arbitrum sequencer, but there are 2 more things we want. We'd like to be able to internalize MEV value that is generated on an Arbitrum chain for the chain and the chain's owners, whether that's the DAO or an application, and we'd like it to be fully decentralized. So first, Time Boost is the proposal to capture and internalize MEV revenue. The idea is pretty simple: to create an sort of express lane in the sequencer, to use the current first-come, first-served sequencing, but delay the non-express transactions by 200 milliseconds. It's a kind of virtual co-location that says, if you're in the fast lane, if you're in the express lane, you can get your transaction in a little bit faster than everybody else. And then each minute you auction off control of the express lane. Whoever is the high bidder, they pay to the chain owner, and then they get to control which transactions can come in through the fast lane. What that means is that you're guaranteeing that if there's a race to capture arbitrage or to back run or some liquidation, something like that, that the party who has bought these rights will win any race that they compete in. And so you can capture the value of that MEV by auctioning off those rights. This captures the MEV revenue. It doesn't sacrifice any of the green checks, any of the good properties of Arbitrum sequencing that I talked about before. So now, once Time Boost again is the implementation is finished, and we expect it to be before the DAO for a decision quite soon. So assuming that your chain chooses to adopt time boost, you can have the next green check to internalize MEV value for your chain. Decentralizing sequencing is the next piece. And this is, and we have a very active collaboration between off-chain labs and Espresso systems to develop and implement a decentralized sequencer for Arbitrum. The idea is, this is well underway, and the work to engineer and actually write code for the system is now starting, the protocol having been designed. So what this does is it takes the currently centralized Arbitrum sequencer, which is trusted today for just one thing, which is to record which transactions have arrived and in which order, trusted for only that and nothing else. But to take that sequencer and to divide it up among a committee of sequencers, so that as long as a suitable majority of that committee is honest, that you get all of the good properties and users are still protected. But you get stronger resistance against misbehavior, censorship, and other kinds of bad activities by the sequencer. So this is underway. It's a current research project and we're not yet at a point where we're talking about dates for this. Okay. The last thing I want to talk about is ZK proving and universal fast withdrawals. When we started Arbitrum, we made a very pragmatic decision that we were going to use the technological approach that best solved users' problems. We were sort of unique among companies in this space in that we did not build the name of a proving technology into the name of our company or our product. We weren't optimistic this or ZK that or Stark this or anything like that, right? The company was Off-Chain Labs, the product was Arbitrum, because we were not married to any particular proving technology. We chose optimistic proving because it was the best fit for the needs of the user community. And we're really happy with that choice. It's still the right choice today. But the cost of ZK proving is coming down over time with cryptographic improvements. And although it's not yet the case, we can see the day coming when ZK proving may be affordable to do at the cost and with the scale that Arbitrum processing demands. So we want to be ready for that. It'll likely be possible soon to ZK prove single Arbitrum blocks on an ordinary laptop. It'll take quite some time to do that, but it unlocks some interesting options in designing an optimistic protocol. But, and apologies for the typo here, we can see a world coming where well-resourced parties, that means parties who can afford to pay for a lot of AWS or similar instances, who can afford a lot of infrastructure or can buy some racks of special purpose hardware, where those parties will be able to ZK prove the whole chain at full speed and at reasonable cost. Because ZK proving can operate with massive parallelism, it's not really so much a question of whether you can ZK prove the execution. The question is, can you do it at a cost that is reasonable, that we think that the chain owners would be willing to pay? We're not yet there. We're not even an order of magnitude from there, but we can see this coming. And so there's been a bunch of work going on in the community to understand how to take ZK proving on board when it is ready, when it is cost effective. And I at least am strongly convinced that the right approach is to adopt a hybrid protocol. Not pure optimistic, not pure ZK, but something where each user, each participant in the protocol can choose whether to take the ZK path or the optimistic path. Essentially what you do is you run something like an optimistic protocol where parties can post claims and they'll be resolved through when time has elapsed. But at any time, anyone can provide a ZK proof to accelerate that process. That allows well-resourced parties to guarantee fast withdrawals, fast settlement to a parent chain in the common case, but it also means that an ordinary user who doesn't have a rack of equipment and isn't willing to pay a huge AWS bill can still guarantee provide that critical guarantee of providing safety and progress of the chain all on their own. So this we think is the right way to go with ZK proving, and frankly it's a matter of research both inside and mostly outside our community to get there. Co-processes and cross-chain interoperability, there's a bunch of interesting things there. I'm going to fast forward through this because I see that my time is just about up. We can, yes, we can make cross-chain interaction faster than finality, and there are lots of interesting trade-offs there. So if I want to leave you with any one impression from this, it's that innovation in the design of the Arbitrum protocol and system, and in L2 generally, is accelerating. We're only going to see more and more progress as the community gets larger and more sophisticated. But all of this, of course, is always in the service of this principle of your chain, your rules. The goal is to create options for the DAO in running its own chains and for each app chain developer in operating their own chain. And I am obliged by law to close every talk with this meme. Let's build Arbitrum together. Thank you.
For our next keynote titled Proliferation of Liquid Staking Across the Globe, What Makes STE a Leader in the Space? Presented by Isidorus, the Master of Validators at Lido. Please welcome him to the stage.